let's talk about being a wizard. To start off, the first problem with being a wizard is that computers aren't magic, and there are no incantations. This talk is actually secretly about learning hard things and understanding complicated systems. So let's do that. I'm going to talk about me for 5 seconds. I work as an engineer at Stripe. I work on a team that's in charge of kind of this stuff, like deployment and like Nginx and service discovery. And always like more, like every few weeks, I'm like, oh, we're in charge of that too? Cool, good to know. And what that means is that there's like tons of stuff to know about, right? Which is amazing. It was just like why I joined the team. I was like, oh, I have to learn about all the things. What could be better? But it can also be hard sometimes. So my goal in my work is to be like, oh, when someone is like, hey, we need to do some work on this system that you've maybe never heard of, to just be like, okay, like, let's go do it. No problem. So this talk is about how to do that. And what I've learned along the way. We're going to talk about 6 wizard skills: understanding your systems, asking great questions, reading your code, debugging, which is like my favorite. Several things are my favorite, as you'll learn. Writing down a design, and understanding kind of the big picture about what you're doing. So first, let's talk about understanding your systems. I like to think of it as like there are things above me and things below me. So like if you're working in like reliability engineering, you need to worry about like things like operating systems and networking, and also like applications and like the business, right? And like we're going to mostly talk about in this talk kind of the layer below you, because that's like my personal favorite. But towards the end, we're going to talk about a little bit of like higher level stuff. Networking, I like networking so much that I wrote a 24-page zine about networking. And how it works, which you can get after, actually. But like, so why is it important to understand the systems you work with, right? And like, why is it so exciting? One reason is that it's cool to understand like jargon, right? Like when someone is like, this program was killed by the killer. It's like, what does that mean, right? We're going to talk about what that means later in this talk. But it's good to just know. But I think more importantly, it helps you to debug harder problems, right? So when I first tried to set up like an Apache web server, maybe like 8 years ago, I did not like understand anything about HTTP really. So what I did was if something didn't work, I would just like Google it and then try random things. And this was like a sort of viable strategy at the time. Like I like mostly successfully set up my web servers. But today that wouldn't really serve me well, right? Because I generally want to do harder things. And so when I'm debugging now, like let's say setting up Nginx, it really helps that I actually understand how HTTP works generally. And the other exciting thing about understanding your systems is that it means that you can actually like innovate, right? So it's really cool to follow like existing patterns. But then if you understand what's going on, you can like build something totally new. So let's say we're trying to understand Linux. Linux is like what, like I don't know, 4 million or like 10 million lines of code. So there's a lot to know, right? So we're going to talk a little bit about how to like chip away one thing at a time until you actually kind of know what you're doing. The first thing that I did when I really started learning more about Linux or about networking was to understand like fundamental concepts, right? So 10 years after I started learning Linux, I was at this place called the Recurse Center, which is like this 12-week programming retreat where you're like, I'm going to learn anything I want about programming. And I was like, well, what don't I know about? I don't know about operating systems. Oh my God, how can I not know about operating systems? I've been using this thing for like 10 years. But it turned out I still didn't know what a system call was, which is like the way that applications talk to the operating system, right? And then so I learned what it was, and since then I've learned many more things. And like similarly with a packet, if you know what a packet is and how a packet is put together, then you can understand a lot of networking things a lot more easily. I have some homework. This is the only homework in this talk. Don't worry. Which is you could actually like build a very terrible TCP stack from scratch. I did it in Python, and it was really fun. And I actually like at the end, after I did it, I like downloaded a web page using my own TCP stack that I wrote from scratch, and I was like, wow, I really feel like I understand like the basics of TCP now, right? Even if I'm not an expert, and that made me super happy. Another thing I like to do sometimes is to do like experiments on my own. So like, if you want to understand, we were talking about the killer, and so you can be like, well, what happens if I run out of memory on purpose? I thought of doing like a demo of this in this talk, but I thought it might go poorly because when you run out of memory, the operating system will be like, oh no, there's no more memory, and it'll just start killing stuff, which might include like my presentation software, and I might have regrets. But maybe I'll experiment after. Another thing I did also while at the Recurse Center was I was like, what's an operating system? And then I was like, well, what if I write one? And then I was like, okay, that's probably too hard. But I did successfully write a keyboard driver from scratch. So if I pressed a J on my screen, I could get a J to appear, like a J on my keyboard, the J would appear on the screen. And I like understood how a keyboard worked from scratch. And I also kind of like learned what the operating system was responsible for by doing that, because I was like, oh my god, I have no files and no hard drive and no like keyboard and no threads and no networking. And I was like, I have nothing. I'm just in like this like formless void with like assembly instructions and a keyboard driver. I have some like personal rules for these kinds of experiments. Mostly that it doesn't have to be good or it doesn't have to work. None of these things that I write are like production ready. My like operating system thing is like this Rust code which has not compiled since 2013, and like definitely nobody is using it. But I learned a lot from writing it. And in fact, after I wrote it, I like passed an operating systems interview, which was like shocking to me. So another thing I like to do sometimes is I like to read books. There's this really delightful book called Networking for System Administrators, which is about like how, if you're a system administrator, how to like communicate effectively with your networking team and maybe like debug networking issues even if you like without talking to the networking team. So this is not like strictly relevant to me because I am not a system administrator exactly, and I don't have a networking team. But it's a really great book, and it taught me a lot about the basics of networking at a time when I felt confused. Another Linux kernel development is also a really good book. And I kind of put it in this category of like reading things that are a little too hard for me. So Linux kernel development, like the goal of that book is to make you into a Linux kernel developer, which I am not. But reading it taught me a bunch of stuff about Linux that I didn't know. And I found it really helpful. Another example of this is like Afir/Kyle Kingsbury has these really great like Call Me Maybe /Jepson series of posts about like distributed systems failures. And the first time that I read them, I really didn't understand anything. Like I didn't know any of the terminology. I hadn't really worked with distributed systems. But I tried to read them anyway, and I would understand like two things. And these days, when I read those posts, I understand a little more, and I'm happy that I kind of read them even when I didn't totally understand. Another thing that is obviously helpful is to work with the thing in your job. Recently, we had like an HTTP proxy, and I did something kind of basic to it. Like I just like added some logging, but by doing even like kind of a like boring task, I learned a little bit more about how HTTP proxies work, which was cool. And the last thing about understanding systems that I like to do is I have this mental model of how let's say Linux works, right? Or how like networking works. So a while ago, we had a machine that was swapping, and I was like, that's weird. And it was weird because the machine wasn't out of memory. It had like 16 gigabytes of free memory or something. And I was like, well, how can it be swapping? It has so much free memory. That doesn't make sense, right? Machines only swap when they're out of memory. And I found out that there are actually several reasons that a machine might swap, even if it has free memory. So we're going to talk for a second about reasons a computer might swap. So it can actually be out of RAM, right? It turns out that it can also be mostly out of RAM, which was not the case. But there's this vm.swappiness sysctl setting where you can say like, okay, you should be like more aggressive with your swapping. The thing that was happening to us was we had a C group which had a memory limit on it, and that had run out of memory. And then like that C group started swapping, even though there was like lots of extra space on the machine available. And the other kind of fascinating thing I learned when I wrote down what happened, and I was like, oh, I learned a cool thing. And someone was like, I'm having the same problem, but it's on a C group. What's going on? And I was like, I don't know, man. And then he tweeted at me a couple of days later, and he was like, oh, did you know that there's this other setting called vm.overcommit ratio? And if you have no swap, your allocation limit is just like your RAM times that overcommit ratio. And so you can end up in a situation where you're like not allowed to allocate as much memory as you have on your box, because the default overcommit ratio is like 50%. So it was like only using 50% of his RAM. And I was like, whoa, that's weird. I didn't know that. When researching this, I also found out that there's a 200-page book on understanding the Linux Virtual Memory Manager, which I'm actually like really excited about. It has like 200 pages of documentation and like 400 pages of annotating Linux kernel code. What could be better? It's from 2007. I tweeted about it yesterday, and people were like, yeah, Julia, that's like the best book. I love it. So I'm kind of stoked now. And a good thing to remember about learning things is that it takes a long time, even to learn seemingly simple things like when does a computer swap. In 2003, my mom bought me a new computer, and I was like, okay, I'm cool, so I will install like 10 different Linux distributions in the basement instead of going outside. And then like 10 years later, I was like, oh man, there are like some like basic facts about operating systems I don't know. That's cool. I'll just go learn those now. And I've gone and learned several things, but I imagine I still have quite a lot to learn. Speaking of having a lot to learn and how to do that every day, we're going to talk about asking questions, which is one of my very favorite pastimes in the universe. So a situation I end up in a lot is I have a ton of like really amazing coworkers. Also, I go to conferences and I meet really amazing people. And I'm like, this person knows like 1 trillion amazing things. And they're like, I'm totally happy to like tell you something. And I'm like, I want to know. And so if I can ask a really good question, then I can telepath the information from their brain into my brain better, right? I can increase like the rate of learning cool stuff. So I have some like tricks I like to use for asking better questions and getting the information that I want. My first favorite trick is to say what I know. So if I'm asking someone about database performance, I might say like, okay, so I know if this database gets a lot of writes, sometimes the hard drive can't keep up, and it's like limited in how many writes it can do by the hard drive, right? And my like database expert might be like, that's right, and then maybe they might say something about like locking or something. They might be like, oh, there are other factors that you're not thinking about, or that you might not know about. This is really great because it helps me organize my thoughts. Because sometimes I'm confused. What am I actually trying to ask? It can easily reveal misunderstandings, right? Like frequently when I say what I know, someone's like, oh, like one part of that isn't totally right. And it also helps me avoid getting answers that are either like way too basic, where I'm like, I knew that wasn't what I was asking, or like way too advanced, where I'm like, whoa, you need to back up like 27 steps before I can understand what you're saying. So I really love that. Another thing that I like to do, especially at work, is to try to avoid asking the most experienced person. So like asking the person who knows the most about a topic is a pretty effective strategy in the sense that like they probably know the answer to your question. But I like to try to remember to like try asking someone who probably knows the answer, but is not necessarily the most experienced person. I think this is cool because it reduces the load on the more experienced person, and then it helps like everyone kind of like grow and establish their knowledge. I know that like I'm not the most experienced member on my team, and I love it when people ask me questions because I'm like, oh, either I'll know the answer and then I like feel good. I'm like, I'm the best, or I don't know, and then maybe I can go learn, right, and then like grow my knowledge. And then that helps like lower your best factor, right? Because then now I know the thing instead of just like the most experienced team member, which is great. It's really cool to do research, especially at work. I'm like, well, if I want to like get like the most information out of this person, maybe I should go like discover some of the basics on my own, and then I can ask a question and like learn like all the really cool stuff that they know, instead of just learning some of the basics. And I think so I also really love to ask yes or no questions. especially about really complicated topics, where if I'm like, how do joins work in this database internally? And like the answer to that question is probably really big. So instead, what I might try instead is I'd be like, okay, I understand this like one join strategy that I've seen before. Does this database use that strategy? And then that's like a yes or no question, and in particular, it's really easy to answer, right? Hopefully. And I like these because they like lower the burden on the answer a lot, because they just need to kind of say like yes or no, and then maybe that'll help like lead them in the direction of telling me what I want to know. One thing specifically about like especially debugging like incidents or like fixing something that went wrong. Sometimes someone will be like, I fixed it, and I will have like no idea how they did that, and I'll really want to know so I can do it myself. And this can be a really good time to just ask like, how did you fix that? Because they just did it, and hopefully they remember how they did it. One thing that happens sometimes is like, so my grandmother makes this really good Trinidadian drink called sorrel. And sometimes she'll tell me how to do it, and then I'll try to do it, and it does not turn out the same. Which is a phenomenon you might be familiar with, because she'll have like left out some critical detail. And so in this case, and when someone is describing to you like how they fixed the database, but like you can tell they left something out because they forgot it. You can just be like, can I watch you like do that? Like, can I sit next to you and see what you're doing? And then sometimes you can like extract the information that you're looking for. And the very last thing about asking questions, which I love, is to ask questions in public. I think this is especially valuable when like more senior people do it, because my experience is that like people who are more senior or more experienced like usually feel comfortable asking questions, because like you feel like more comfortable with like more secure in your knowledge. So you're like, I don't understand, and you're like, you don't like worry as much that everyone will think you're dumb. So if if like senior engineers kind of like ask questions in public and are like, I don't understand how that thing works, it like opens up space for everyone to ask that, right? Which is what we need. The next thing I want to talk about is reading the code, kind of like that thing with like 400 pages of annotated Linux kernel code, except probably easier than that. So I love this. I want to talk about a few reasons I love this. It's really cool for understanding mystery error messages, because sometimes there's an error message which is just like, the thing doesn't work. But if you go read the code and see where that got printed, maybe you can find something more descriptive that actually explains what's happening. Another thing that comes up a lot is like, I'll want to know how something internally works. It won't be documented because it changes really frequently. And then I'm just like, okay, I'll just go find out. This is great. And I find it pretty easy to do this for like internal projects or projects that I've worked on, like code that I've worked on. In my first job, I was asking my manager at the time, like, I was working with Drupal, which is this PHP content management system, and I had like a really specific question about how a specific thing worked that I needed to work with, and I was like, I don't know how this works, it's not documented. Do you know how it works? And he was like, no, I don't know how it works either. And he was like, you have to just go read the Drupal code, Julia. And I was like, oh, but this is like huge, like PHP code base. Like, how am I supposed to go read it? But he just showed me. He was like, look, it's right here. You can just see what it does. And I was like, oh man, I can just see what it does. This is cool. I can get all the answers to my questions. And since then, a little while ago, I went and I like read some like Nginx code because I had a question about how something in Nginx works. And I was like, oh man, I can totally understand this, or at least like a very small part of this, even though I don't know C. And I haven't really, or like I vaguely know C, but I'm not an expert, and I've certainly never contributed to Nginx. Okay, now we get to talk about debugging, which is, I think I said my favorite thing. So I'm going to tell you a short debugging story that happened maybe a couple of years ago now. So I had, there's a client and a server, and the client was making a request, and it wasn't getting a response for 40 milliseconds. And this was happening like repeatedly. a lot of times because we had like monitoring and we could tell how long it was taking. So I saw that it was like always taking 40 milliseconds, and I was like, why is this happening? This isn't good. And in particular, the client and the server were on the same computer. And I was like, that's weird. Like, it shouldn't take 40 milliseconds for you to talk to each other. You're on the same computer. That makes no sense. And like, that's really slow, right? Like, if you're doing those like synchronously, that's like 25 requests a second. What's happening? That's no good. So I got like a packet capture of the packets. And what I saw was that the client would send in some HTTP headers, and then like 40 milliseconds was fast, and then it would send the rest of the request. And then the server would send a response right away. So originally I was kind of like blaming the server. I was like, what are you waiting for? But it turned out that the client was totally to blame. And I was like, oh man, what's happening? This makes no sense, right? And I was like, should I blame, it was in Ruby, and I was like, should I blame Ruby? Like, spoiler, it was not Ruby's fault. As much as I thought it might be. So it turned out that what was happening was there was this, this had to do with like how TCP works. So there's a thing called delayed ACKs and a thing called Nagel's algorithm. So with delayed ACKs, the server like won't send an ACK right away for like efficiency. And with Nagel's algorithm, the client like won't send another packet until it gets an ACK. So the client would send the first packet, and then there was this like passive-aggressive waiting situation where the server's like, I'm waiting for the second packet, and the client's like, yo, I'm waiting for an ACK. And then at some point, the server gets bored, and it's like, okay, here's an ACK. And the client's like, here's a second packet, and then everything is done. The only reason I figured out this was happening, because I'm not like a TCP expert, though I did kind of know the basics of TCP because of my terrible TCP stack, was that I read an article about it. I'd read an article about it before, and I was like, oh, that sounds like that weird thing, like the weird passive-aggressive waiting thing that I heard about before. Maybe it's that. That would be so exciting. And I was like so excited. And then I set TCP no delay, which made the client stop waiting, and then it totally fixed all my problems. And I was like, oh my god, we're wizards. And a while after that, I was like, oh man, I feel like I'm better at debugging than I used to be. Like, let's say, like in my first job. And I was like, how did that happen, right? Like, why? What does it mean to be good at debugging, and how do you become that way? And so I think some things that helped me were to like remember that the bug is happening for a logical reason. Frequently, I like react to computer bugs where I'm like, that's impossible, right? Like, why is this thing? Why is it like this 40 millisecond wait? It makes no sense. But like, it's always true that you're like, well, it happened. And there's always a reason. They're just computers. Another thing that really helps me is to like be confident that I can fix the bug. This is kind of a hard thing, but a while ago I was trying to fix a Hadoop, like a MapReduce job that was really slow, and it took me like 2 weeks to fix it, which is kind of a long time. And it was really helpful to be like confident that I could fix it, because if I didn't, I was like, oh, I don't want to like waste 2 weeks trying to fix a thing that I like, and then have it not work. But I did in the end, and then I felt really happy, and I was happy that I kind of like persevered and was like, and I had some like tenacity, right, where I was like, no, I'm gonna win. Though of course, it's good to make sure that the thing is worth spending 2 weeks on, which this was. A couple of things I learned by doing that is that floating point exponentiation is extremely slow, because that's where this job was spending like 98% of its time, which was kind of exciting. And another thing I learned was that it was like each worker was processing like 1,000 records per second. And I learned that isn't really a lot. Like, it was like a Java program, and Java's pretty fast. And so I actually really struggled with this. I was like, is 1,000 per second a lot or not a lot? And like, how do you know what a lot is, right? And how do you get better intuitions about that? So I decided to take some time to like train my intuitions, because I was like, that feels slow, but I don't know. And I actually made a game called Computers Are Fast, which you can go play if you want. It's at computers-are-fast.github.io. And we're going to play it right now. So let's see how it goes. One question in this game. So they're all of the form like, how many times per second can you do this operation, right? So like if you're like going through a loop in Python, I think it turns out that you can do like 10 million per second. loops in Python. So let's say we have a database table. It's a SQLite table. It has 10 million rows in it, and it's indexed, right? And let's say you want to select a row from that table with a given ID. And like, how many times per second can you do that? So I actually want you to like think about how many times you can select a row from this table for a second, and then I'm going to tell you the answer, which is like 55,000, which is reasonable, I guess. This is in Python. And the thing that I found interesting about this was like when I wrote this game and when I tried out these problems, I was really frequently off by like orders of magnitude, right? I'd be like, oh, maybe this is like you do 1,000 of these, and it was like, no, actually you can do like 1,000,000, right? I'd be off by like 1,000 times, which is probably more than can be accounted for by like hardware differences, right? Because probably like the server I'm running on is not like 1,000 times faster than my laptop. And I think having these kinds of like basic intuitions about how computers work is really useful. Another thing that's really helped me is to know my debugging toolkit really well. So like with this networking problem, I wanted to know like what do these requests look like, and like is the client at fault or is the server at fault? Like previously, I often wouldn't know how to get the answers to these questions like this, and now I have a much better toolkit of things like TCP dump. I got so excited about like knowing my debugging toolkit that I wrote another zine about Linux debugging tools that talks about like TCP dump and perf and like a lot of tools for like understanding like what's happening inside your Linux computer, and it's made a really big difference to my ability to debug things. The most important thing I think about debugging is that I learned to kind of like it. So like when I started programming, I was like, oh no, there are bugs. This is just like getting in the way of me coding and like making me slow, and this sucks. But now like if I encounter a bug that's really hard, I think it's kind of exciting, right? Because I'm like, oh, I don't understand what's happening here. Maybe I'm going to learn something new. That's cool, right? My favorite days are days when I get to learn something new. That's the best. So we're going to zoom out for a second now. We've been talking a lot about like milliseconds and like the killer, and we're going to talk a little bit more about higher level things when you're working on projects. One thing I learned in the last year, I think, was like a little bit more about how to design like software and projects and systems. So there's the idea of like a design doc, right, or like a project brief or an RFC, which is basically like you're working on a project and then you write down like words about that project before you do it. And in the first couple of years of working at Stripe, I was like, I don't understand what this is. Like, can't I just start working on the thing? This seems like kind of a waste of time, right? And then I was like, oh wow, this is really useful. Cool. So maybe you all knew that already, but I'm going to tell you about it anyway. So I was scared of a bunch of things, right? Like I was scared of like I would write something and like everyone would just tell me that it was wrong, or that maybe I don't know if this is worse or better, but like I was worried that no one would tell me anything. But in practice, one thing that's really helped me was to try to design like small projects. So recently I did a project that just took like maybe like a week. It was pretty small. And at the beginning of it, my team lead was just like, hey, Julia, can you like write a document about like what you're going to do? And I was like, yeah, totally, because I believe in these now. And so I spent like 30 minutes writing up what we were going to do. And then the manager of another team was like, oh, wow, this is so useful. Thanks so much for writing up what you're going to do. And then he told me a couple of things that were actually like needed change. And I was like, okay, great. Now we all like agree about what's going to happen. And then we did it, and it went super well. And I was really happy. And I was like, that was totally worth 30 minutes. Another thing that I really love to do is to write like the announcement email for projects I'm working on first. I find this helpful because like I get to answer a lot of important questions, right? Like I'm like, okay, here's this really cool thing we did. This is why it's important. It's gonna have like a little bit of impact on like these teams. Here's what you need to know. These were our goals, and like here's how we know that we met those goals. And I find this kind of like motivating because then I have this like thing explaining the cool thing that we're going to do, and like how it was so great, and it really helps me. I think that like the how do we know it's working I find especially helpful because sometimes I get to the end of a project and I'm like, oh, how do we know this is working? Oh no, right? Like, so I like to kind of like establish that up front. Another thing, I haven't actually done this, but I think it's a really cool idea for bigger projects, is to like write like a pre-mortem. So you're like, okay, it's like 6 months in the future and this project totally failed. Like, what happened? And so there's an HBR article about this, and I kind of want to try this. And it feels like an easier way for me to think about like the risks of a project, right? And what might go wrong and like how to mitigate those risks. But I just be like, it failed, and then try to imagine why. And I also really love like tracking changes. Earlier on, I was like, why should I design this? Everything is just going to change anyway. This is like a waste of time. But it turns out that change is normal. I wrote like a document a while ago, which I think is for a project which we're like not going to do in that way at all. But we are probably going to do it in a different way. And so I'm really happy that like I wrote down everything that I thought about how we were going to do the old project, so that we can decide, so that we can like take stuff from that and be like, okay, these are the things that we want to be the same, and these are the things that we want to be different, and then we can see like what the difference is. And it's actually just really useful, and I'm happy I didn't worry that things are going to change, because of course they did. The very last wizard skill I'm going to talk about is, so have you ever like been working on something, especially something kind of tedious, and being like, you're just like, why am I doing this? And like, what is like even the point of this project? And like, why have I been like trying to like configure like Nginx for like 4 hours? And like, anyway, so this happens sometimes, and I don't really like it. And one of my goals is to like approach like things like project planning and like the work I'm doing with kind of the same excitement and curiosity that you can approach like debugging with. So you're like, okay, what is the thing we're gonna do? Why are we doing that? Why is it useful? Why is this cool? And I have in my job a lot of like autonomy about what I work on. So I like to, when someone suggests that I do something, I'll be like, okay, why is this thing important? Or should I be doing something else, right? And normally what happens is I'll figure out why it's important and then go do it. But sometimes like the thing that the person suggested will like, maybe they only thought it through like maybe 80%, and then when I go investigate it and make sure that I really understand why we're doing it, then I'll be like, oh, we could actually do something much simpler, or maybe we don't have to do this at all, which is great, because then I don't get to the end and realize that it wasn't really necessary, which sucks. And understanding the big picture really helps me make better technical decisions, which is great, because sometimes I'll be like, oh, should I do X or Y? And then I'll just be like, well, why are we doing this? And then I'm like, does it matter like at all whether we do X or Y? So like if I'm trying to do a project for like security reasons, maybe I don't really care about like optimizing for performance because that like isn't a goal of the project at all. And working on projects that people care about is super awesome and makes me feel happy. And like I think it's easy to like want to work on like the hardest projects. I mean, I kind of also want to work on like hard technical projects, right? But in some sense, like if I can do something which is really simple, which can make a really big difference, that makes me really happy. And so if I like spend like kind of like keep a good picture of what's important, and like what has a big impact, and maybe I can do like something really easy that does that, which is great. Okay, so we are now wizards. This is everything we talked about. And of course there are many more wizard skills, right? Like we didn't talk about many things related to working with people, and people are like the hardest things. So I have only 2 things for you. Well, 3. One thing that I hope that you'll do is to like ask questions of all the delightful people around you, because I know that's what I'm going to be doing in this conference. I have like 1,000 questions for you, I'm pretty sure. And the other thing that I'm excited to do, and that actually like writing this talk really inspired me to do, was to like go read something that's kind of hard, right? Like there's this like 200-page book about Linux and like how virtual memory works, and I'm kind of excited to go read it. Maybe, yeah. So maybe go learn something that's like kind of out of your comfort zone. That's all I have to say. The very last thing I have for you is I have a present at the front. I have a zine about computer networking that you can have. That's all. Thank you.